Hello students, in this video let us see the disc pack and the cylinder. In the last videos we have seen about the magnetic tapes and little about magnetic disc. In this video we'll see how it actually works. So this is how a magnetic disc is arranged. So this is the arm assembly, this is the read or write head, this is called the arm, and it rotates in this direction. There's a rotation, and this each one is called a platter, and this is an imaginary line that passes through the discs, and we call it as a cylinder C. And each division on this platter we call it as a sector, and this each track on the disc, that is a circular path, we call it as a track, and the axis along which this disc moves we call it as a spindle. So what happens is, see, these are the disc that is mounted to the spindle, okay, and there is a arm assembly, and we have this arm, and at the tip of this arm there is a read or write head. Now what happens, our intention is these platters are used as a storage devices or the storage tools. So if you have to store something, what we need to do is, your head has to write something on this disk. If you want to read also, these heads are used to read anything from this disk. And how it is read, you might have seen some of the CDs or optical discs working. So simply put, it just rotates. So if at all you need to read something on this disk that is at this distance, let us say this is a thing that has to be read. So this disk has to move or rotate in the way that it reaches this head. Okay, in case this sector, this is the smaller sector, let us say, and there's a bigger sector in this path, okay, at that time this arm has to move either front or back so that it is read. So there is a work for this arm as well as the spindle to rotate this disc to either read or write. We'll see how this happens exactly. So as we have seen, there are many disks that are maintained and used together to create a larger disk storage system. All the disks are stacked top of each other, that is one above the other, with the common spindle which rotates them. And there is a gap between each platter, so it can perform a read or write operations. That is, arm is mounted to this platter, and all the read and write of each discs are attached to single arm assembly. That is, one arm assembly is there, and there are many read and write heads respective to the discs, okay, and the read and write heads are on equal diameter track on the different platters, one at a time. Then tracks of equal diameter on a different platters form a cylinder, okay. So that imaginary line what we saw, we call that as a cylinder. So that cylinder can go on increasing with respect to radius. So how the data is read from this, accessing or writing to this, we'll see it. Data in the magnetic disk is recorded on the surface of the circular tracks, as we have seen in the diagram, okay, with the help of the read or write head, which is mounted on the axis arm assembly. So these heads can be in multiple numbers to access the adjacent track simultaneously and making the disk faster. In this we had seen only one head, but if at all there are like heads at both, there are two arm assembly and two heads for each platter, the reading of information from the disk will be easier and faster. The axis arm assembly can be positioned both inward and outward directions so that read and write can move the horizontal surface of the disk. That is, either it can come into the center of the disk or it can move outer to the outer layers. Okay, if there are more than one disk, then the surface has its own read or write heads that works in harmony with the other read or heads to record the data. Okay, it's like if it's more than one, so one read and write head will not be sufficing, so we'll have more than one read or write head. So there are three main things related to this. We call that as a seek time, rotational delay, and data transfer time. So the step it includes is one is seek. You might have heard what a seek is. We'll see that. And rotate, that is rotation of the disk, and the data transfer. And the time associated with this we have as a seek time, rotational delay, and the data transfer time. So what actually happens? See, let us consider there is an arm assembly here, and this are the arms, that is which has a read or write head. Okay, here it is amplified so that you can see what is actually happening. This is again the block diagram. Okay, for your better understanding, it has been done. So this is the axis arm. Okay, so this can move front or back. As I told you, see, this is the imaginary line. If you say it passes through the center of the disk, which we call it as a spindle, so there is information that is to be read in either in this space or in this space. This arm has to move inward or forward. That is, if it comes forward, it comes near to the center of this disk. If it moves forward, it comes to the outer surface of this disk. Okay, so this is the disk surface and there is a read and write head. So the time to which the data has to be searched on the disk, like where exactly the arm has to be placed, okay, that we call it as a seek time. And I don't know if you have seen in the some of the media players, there will be like you will just forward it, right? How will we do that? We'll just click on the a small button that is movable, right? We'll click on that and we'll just drag it to the space we want, for the place we want, and that we call it as, that action we call it as a seek. Okay, and the time required when you do that, like when you physically on the computer, if you do that, the thing that actually in the disk that data has to be located, the time taken by the axis arm, we call that as a seek time. Okay, so you might have seen it is not like it is fast, quite fast, but still there is some time gap, right? From the time you start to drag the button to the space where you stop it and the video to be played, there's a very small time gap, that we call it as a time required to do that for the system. Okay, we call that as a seek time. Next is the rotational delay. Rotational delay is, see, your arm can move only forward and backward, right? If your data is here, what should be done? Your disk should move from this space to here so that the information is read by the head. That is, if at all the data was here, it has to rotate till here so that it comes under the reader right head. For this, the rotation that has to happen, whatever the to the angle it has to be rotated, we call that as a rotational delay. That is, once the data which is present here to come for that under the read or write head, the time required for that, we call it as a rotational delay. You might know that these are very small amount of time. Computer is a very fast machine, so the time required is very small, but still it requires at least some time or a moment of time so that the information is read. And the process for this, we call it as a rotate, and the time taken, we call it as a rotational delay. Okay, now if the information has to be returned to this, that is, you have to write something on this disk, what happens? It is again not that simple. What happens? This arm should get the information what you want to the right head. Okay, and this right head, what does it do? With its own time consumption rate, it transfers the information to the space provided. That is, it starts writing or putting the information here, and when it fills, it has to move a little forward and again the information is written there. So this goes on, like slowly the disk moves and the information is written to this. And for this, we call it as a data transfer time. And you might have known that if you have used CDs or something, when you burn the CD, that is, you are actually transferring something to the CD, there is a time, right? it will be showing the percent of amount of data transfer has happened, the percentage it shows on the screen. So that we call it as a data transfer time. So let us see what happens exactly during this process. So the data process and the data comprises of accessing time, that is one is seek, and as I told you, the heads are positioned in a specific track on the disk platter. The time taken in doing so is called a seek time. So average time required to move the heads from the desired track on the disk. So it may range from 2 to 15 milliseconds, and commonly it's a 9 seconds, 9 milliseconds. Rotate, that is the movement of the disk from where the information is there to be read by the disk arm. The disk has to be rotated to in certain angle, and that we call it as a rotate, or the rotational delay, the amount of time taken. So it is rotated constantly, that is I told you, usually you cannot notify this delay, but there will be some kind of wait that will be that has to happen. And so this waiting time is called rotational delay, so or the latency of the disk. So that is around 7200 rpm, that is rotation per minute, and 4.17 milliseconds approximately. Usually it takes so much of time to be rotated. For data transfer also same thing, the data should be transferred from the arm to the disk, and it is also the rate at which the data read per from the or returned to the disk. This is known as data transfer rate. It could be either like copying into the disk or copying something from the disk to the other devices. So it is measured in kilobyte per second, and the data transfer rate per rotation will be 64,000 bytes. So for 1 second it is usually 6.4 MB. Okay, so this is how it works. So let us see some of the magnetic disk types. So magnetic disk, when we say, it is usually in a round platter form, different size and designs you get it. And just read and write assemblies, if you put it to it wherever the information, the platter is there, then you can get the information. Okay, and mainly it is divided into floppy disk, hard disk, and zip disk. We'll see this one by one. So this is how a floppy disk looks like, and these are one of the oldest, not like very old, but it was present in around 90s and all. But nowadays you have the pen drive. So pen drive has replaced almost every secondary storage devices now, pen drive, and especially the hard disk that has a very large capacity. But at that time, a small amount of data was great enough to work on it, so these floppy disks were used. So this is a floppy disk drive. So here we insert the floppy. Like if you want to eject, you need to press this button, so the floppy disk comes out. It's same thing like if you have seen how a CD works. Okay, that you press it and the CD, that player comes out, no, where you insert the CD. Same thing is done for this. So this is our disk drive, floppy disk drive looks like. So if you want to say how it is, how it looks actually inside the making, it's a round actually inside. It's a flat piece of mylar plastic coated with the ferric oxide and encased in a protective case plastic cover. See, this is what we saw there. There were square boxes kind of thing, no, that very thin case it is. Inside of there is this magnetic disc, and it is a removable disk and is read and written by a floppy disk drive, including reading, writing data, and rotating the disk. And the head alters the magnetic rotation of the particles, where the orientation of one direction presents one, and if it is rotated in different direction, it is given as a 0. So see, this is the drive, and we insert the floppy inside this. So floppy enters this, and this is how the looks like inside the drive. So this is the light, like whether the floppy is there or not, there will be some LED light blinking. and this is the button for either to insert or eject. And from this part we insert this floppy. So this is the drive spindle, that is where inside the platter, the center, where the disk platter usually rotates. And this is a info light is passed, so to see whether you can some floppies are like you can write it, some are not rewritable, so that is checked here. And this is a stepper motor cover, access cover, and read write head. See here it is. And this is the floppy disk drive with the case. There is outer case, and inside this there is actually the disk. So how does the read write option operation happen in floppy disk? So first you insert into the drive, and it's a you might have seen like the CD drive also, like it's same thing, it's made up of and when the drive is sorry, when the floppy is inserted, it grabs the disk inside and spins inside the plastic jacket. The disk rotates inside the plastic jacket itself. Okay, you like physically you cannot see the disk, it's only the case you are seeing, the outer cover you are seeing inside the disk, but inside it is rotated. So it has multiple levers that get attached to the disk, and one lever opens the metal plate or the shutter to the exposed data and access area. Other levers and gears move to read or write heads until almost touch the diskette on both the side. So the information here is written on both the side of the disk. Okay, so accordingly the read and write also happens. And the drive circuit board receives instructions either for reading or writing. And if the data are written on the disk, the circuit board first verifies that no light is visible through a small window in the floppy disk. If the photosensor on the opposite side of the FTD detects a beam ID light, floppy drive detects to be write protected and does not allow the recording of the data. That is, you cannot write into the floppy if at all there is that photosensor detects that this is a this is write protected. You cannot write into it. Only information whatever is there in the floppy you can read it. Okay, that is a mechanism in this floppy. And it translates the instructions that whatever is written on the platter, and a motor located which we have seen in the diagram, so it spins the shaft and engages the notch on the hub of the disk, causing the disk to spin. So basically you can say that that shaft helps in the rotating of the disk. And when the heads are in the correct position, that is where the information you want to read, in what space of the disk you want to read, the electrical impulses create a magnetic field in one of the heads and write data to either the top or bottom of the disk. As I told you, read on writing on the disk happens on both the sides. If you see CD and all, you are just inserting only one side, it's being read or written. Okay, but here it's a magnetic disk, on both the sides you can write and read. And on reading the data, the electrical signals are sent to the computer from the corresponding magnetic field generated by the metallic particle on the disk. That is, uh, the whatever the magnetic electrical signals are read from the disk. See, that is just a storage device, and when information is stored, that has to be sent to the computer. Okay, then read what actually it means, like what is the command or what is the thing stored in it, it is read by the system. So floppy disk head touches the diskette, then both the media and head wear out quickly. Okay, so this, to reduce this wear and tear, what is done, personal computers retract the heads and stop rotation when a drive is not reading or writing the data. That is, in case, like if a floppy is to be read, it has to be rotating all the time. But if at all, if you just insert and it keeps on rotating all the time, even if you are not using the system, that is floppy disk, the head gets wear out in the sense it gets spoiled, or you should repair it or replace it. Okay, so what is done, if it finds that this floppy is not working, it's just inserted, it will directly stop the running of the floppy. Okay, then read or write when only when next command is given to read or write, only then it starts rotating again. So that is the thing. So hard disk is which you are all aware of. Every computer has a hard disk, and it's also called hard drive or fixed drive because you actually cannot move it. Like it's not movable from one system to another that easily. It's like at least by the user. It like the admin or whoever is like repairing the system, they can replace it. That is not a problem, but still it's not for the user to actually replace it. So it's a primary unit of the storage unit of the computer. Like it's a main memory where everything is a store. It's not the main memory. It's a primary storage, like secondary storage device. In that category, it is the main one. Like okay, it acts as a main storage device, and it consists of a stack of disk platters that are made up of aluminum alloy or glass substrate coated with the magnetic material and a protective layers. This is how it is built. Okay, they are tightly sealed to prevent any dust particles which causes head crash from getting inside. So what happens is these since these are magnetic ones, as I told you in the tape also, if the dust and humidity enters this, it's again difficult for this also, to read and write. So that is why it is totally sealed. Okay, you cannot, dust, and there is no chance of dust or humid entering this system. Okay, and that is why we need to, like keep operating this. As soon as you on the system, these like get activated, so there is always heat. So the question of humidity accumulating in this also is not there. So so that is why it's built inside a tightly sealed case. And hard disk can be internal or external. You have might seen the external hard disk that we insert to the system when the internal memory gets full. So which can again hold a very large amount of data. So this is how it looks like. Okay, the hard disk. This is the platters, that is the magnetic disks platters, and there are mechanisms that actually used to read the information from this. So this is of a laptop. This is how it looks like. This is of the desktop. The capacity is the amount of information that a hard disk can store, measured in bytes. So usually a computer comes with the 80 to 320 GB of hard disk. Now the limit has increased because nowadays how much ever data space is available, it's not enough. That is why it's increasing. There's a like typical computer comes with this one, and it is measured in terms of access time, the hard disk speed. That is how fast the system can access information from this hard disk. Hard disk with lower access time is faster, okay, than the hard disk with the higher access time. So what are the things that we saw in the magnetic disk, like how it is actually working? So this is a spindle, and this is the arm, disk arm, what we have seen. This is a protective case. See, inside this it is present. So these are the platters, and this is the read write head. See, there are one more read write head here and one more here, that is for each disks. Okay, so this is how a typical hard disk looks like. So how is the read and write operation happening here? Happens here. um, it uses a round flat discs made up of glass or metals which are coated on both the sides, as we have seen in the last slide. And it's both the side is coated with the material that is specially designed to store the magnetic patterns. And it has information recorded in tracks, and which is further broken into sectors that we have seen in the last video also, like how the division is made on these platters or the discs. And it rotates in a high speed, driven by this special spindle motor connected to the spindle is at the center axis of these drives, sorry, the discs. And special read or write devices are mounted onto the sliders, and used either record data onto the disk or to read data from the disk. That is sliders are used like like read or write head, and it's mounted to the arms of the disk and a mechanically connected single assembly and position of the surface of the disk by a device called actuator. And each platter has two heads, one at the top, one at the bottom, as I told you, because that information is written on the platter and below the platter, below each one. So this head, read or write head, is present on both the upper and lower part of the platter, and it's recorded into magnetic surface of the disk, exactly same way as the floppy disk. And it's a array of dot positions, and each domain of the magnetic polarization set to binary, that is 0 and 1. Only this 1 or 0 information is stored on this disk, and later on converted to the information that we need. So first, the file allocation table, FAT, in Windows. You might have seen some of the FAT files, some extensions as FAT, and at the beginning of the partition it has to be done. This tells the operating system which sector and track to find the data. Okay, that is information where exactly it is stored on the system, that is on the disk. Okay, then with this information, head is moved to that the requested space or the file where it is present. And the heads in the most of the hard disk is slightly above the surface, and this the distance is very much less, even it is lesser than the human hair. That is why even a small or very small dust will cause your system to damage or not to work. That is why it is very you know tightly sealed so that no dust enters. So, if at all head accidentally touches the media because of electrical malfunction or so the disk get scratched. And where this disk is scratched, you cannot read this, and then that we call it as a head crash. Okay, that information we cannot read it later. This is one more type. This is a zip disk. This is how it looks like. So this is the zip disk drive. So it is removable storage device, okay, and it has a capacity about 100 to 250 MB of data, and the case is like 18 cross 13 cross 4 centimeter and weighs about half kg. So it's rubber feet to stabilize the unit in either vertical or horizontal position. This is like either you can keep it in a horizontal or a vertical position, and it's again made up of plastic material, and magnetic oxide particles are coated to it. Okay, and there are two indicator lights, green for power and amber for disk access. It has a eject button, again on and off, same thing like you are a floppy disk. So diameter is similar to 3.5-inch floppy, and it again requires a separate drive. You cannot put it in a floppy disk drive or any other drive. It needs the zip disk drive, and there are so many versions of it which can hold up to 100, 250 or 750 MB of data, and it can store about 70 times more than that of a floppy disk. So these were the early things that were used instead of pen drives or CDs that are available now, and it can be used to store heavy graphics, music, or presentation files. If the even though the size is a little bigger, also you can store it. That is why heavy graphics can be used. So these are the types of magnetic disks that we have seen. So what are the advantages? If we summarize, we can say that it's a direct access one, unlike the magnetic tapes, and it can be used for both online and offline storages. And since the size is small, it is movable. Even though hard disk is we don't usually move, but to some extent it can be moved, like portable it is. And data transfer rate is higher compared to tapes, and low cost, high recording densities, that is the space available is enormous. You can use a large amount of space is present, and you can record or store anything on it. And compared to the space, or you can say the cost per magnetic disk, that is very minimum. And storage capacity is again unlimited, like you can have any number of hard disk. That is the thing, and until you need to have a port to be attached, but otherwise you can have any number of um, disks attached to your system. And the less prone to corruption, that is somebody externally altering the information, that is not possible usually. Still, there are some disadvantages like the dust-free environment, what we have spoken before. That's very, very important. Even a very small dust can cause your system to crash. And it's if at all you need a sequential access itself, like one after other itself, you need to search something. This kind of the disks are not advised because it's a direct access one. And comparative magnetic tapes, these are costly. Okay, compared to the density of information it stores, it is cheaper, but compared to magnetic tapes, this is costlier. Okay, then they are more susceptible to breach of security, access to gain sensitive online disk files from the remote terminals. It is safer, like from the place where it present you cannot get the information, or you can just simply can't take it. But if it is available online, like if the disk is for the online storage purpose, then you can use some of the uh, softwares maybe, or somehow you can just get the information if it is put online. So the next thing is a most familiar one, that is optical disc. Why do we call it as a optical? Because the light is the main one that actually works. Optical or optics is nothing but like study of lights, and using the light, these discs are working, or you can read or write information from the disc. Unlike in the magnetic disc and magnetic tape, it is the magnetic oxide layer that actually contributes to the mechanism or the working of the system there. Here it's a light, or just a plastic disc that written and read with the help of a highly focused laser lights. Okay, so to see it, it's a flat circular plastic disc coated with a material on which bits is stored again in the form of zeros and ones, and the light reflective areas are a kind of different. It's built such that if the information written, it is very easy to get the refraction of the different um, values, so that the information written on this can be read. So the storage data may be read and illuminated in narrow beam source such as a laser diode, as I told you. And these disks are capable of storing huge amount of data in limited amount of space. The capacity, you might be knowing, it is very large compared to your magnetic tapes, or just magnetic single disk. Okay, and it consists of a rotating disc coated with a thin layer of metal that acts as a reflective surface and a laser beam, which is used to read or write ahead of the recorded data. So it comes in various sizes, again three types mainly, that is CD, DVD and a BD. So you are mainly familiar with the CDs and DVDs, okay, compact disc and the digital versatile disc. There is a new one like Blu-ray disc. It's not actually new, but compared to other two, this is a new one. But nowadays, again, these things are also becoming obsolete because everything is being replaced by the pen drives, or the storage device like memory cards. So it requires different types of disk drive, but CD can be also read from a DVD, drivers. Even if a driver can read Blu-ray disc, then it can read all the three, that is DVD and as well as CDs. So CD comes with the 700 mAh capacity, that is 12 centimeter in diameter, and it's popular. It was popular at least, and the storage capacity is a huge. Cost per disk storage is very low. That is the when the amount of information it is storing and the space it requires, the rate or the amount is very, very low. So how we can actually store in optical disc? It consists of a single long track, and rather than like magnetic disc, which is a concentric circle, right? In magnetic we have seen the concentric circles. Here it is a single larger track, and it starts from outer edge to the and comes to the inner edge. We'll see the diagram in the next slides. And it's spiral in shape, and the track makes the optical disc suitable for storing large block of sequential into onto it, such as music. That is music like which is played one after other can be easily stored in this type. And in case of magnetic disk, it is easy to locate magnetic disk tracks since they are located in a fixed distance from the center. But these tracks are further divided into small sectors of the same length irrespective of the location on the disk surface on the CDs or DVDs, that is optical disc. With the more data recording density, that is more amount of data can be stored in less space. These have more complicated mechanism compared to your magnetic disk. Okay, so the rotation speed varies inversely with the radius of the disk. That is, see, if the radius is higher, what has to happen? Your disk has to move fast. But if your radius is smaller, that is, in the sense, we are talking radius in the sense it is a in the center of the CD something is present and you have to read it. So what happens? The speed becomes lower because it's only small space to be read, right? So as it comes out into the outer, like, edge of the CDs or DVDs, optical disc mainly. So what happens? The speed, it increases. Okay, so the disk moves slowly when the data is read near the edges and move fast when it is close. And its operation performed through a laser beam, hence no access arm is required. That is, only a laser is used. See, when we say light, we can just move the angle of the light itself when falling on the disk, right? We don't have to have a arm or a head to read or write. See, this is how a magnetic disk look like, that we have seen. See, this is the center. It is divided into these concentric circles. That is, see, this is track of one radius. This is the track of another radius. This is the track of one more radius. So all these things. But here it's a spiral. That is, the laser beam falls on one end from the outer edge of the disk. It just goes on a spiraling inside like this. See, there is no end, and at the end only it just ends here. Here it is a last bit of data that has been recorded. Okay, so generally access time for optical disc is a 10 to 40 milliseconds. So how the access mechanism works? So laser beam technology is used for reading and writing, and it uses two laser beam from different sources and intensities. Greater intensity is used for writing on the surface by turning it on and off at various, varying rate, so that pits are burnt into the metal coating of the disk. See, that is, on the CDs or DVDs or what optical disc, there is a metal coating, and I told you this is only one sided. That is, at the bottom itself, it's a being a burnt, or the information has been stored. So what happens? The laser beam with the high intensity is put, and if the for the again the information stored at only in zeros and ones. So when the metal oxide, on the metal oxide, when this laser beam is focused, there will be pits forming. Pits are nothing but, or you can say a tiny depression, or just a kind of dent, you can say, that forms on the this metal surface, that is a metal coating of this plastic disc. Okay, the lesser intensity laser beam is used to read the stored data. That is, just to read, a lesser beam is used, and it is, the thing is, it is reflected by the coated surface called land. So there are two things, that is land and pits. The land is the a plain surface. Pit is the one that is actually formed with the a little depth compared to land, and it is weakly reflected when burnt by the surface called pit. So the change in pattern is detected by a photosensor and converted into digital signals. So that is zeros and ones. I told you the information stored is only in the form of zeros and ones, and in this way it is read. See, this is how it looks like. I told you only in the lower part of the disk. See, this is the upper part. Okay, so you can think of it as, this is the center, and this is edge of the disk. So this is like transversal section, and this is the pit, this is land, this is a pit, this is land. So what happens? See, this is a laser beam that passes through a prism. You might have seen a prism. It's like triangle shaped with the rectangular base. So it has a property of converging or diverging the light that comes from a laser. Okay, not just laser, any light for that matter, but here it is for the laser. And when it hits the land, that is which is a normal surface on the CDs or optical disc. So when it comes back, it is read by the sensor, and sensor reads whether it is 0 or 1. And when it hits this projection or a dent, whatever you can say. Dent is compared to this CD. This is one, this is the dent. And this laser enters again as a usual thing on the prism, and it hits it and it escapes the prism. See, the ray does not pass through the prism, it escapes. And the sensor notes that there is no light passing through it, and there is no light passing through it, so it is read as 0. So in this way, every information on the optical disc is read. So this is how a CD looks like, that is compact disc. See these lines, or that reflection on this CD, what is it? It's because of the metal coat that has been coated. So this is the back side of the CD. Like front will be you will be have put a sticker of what it is, like maybe some movies, a CD or whatever it is. That sticker is put, and only at the back the information is being written. So there are types of optical disc. Um, some are used for storing music, that can record up to 80 minutes of uninterrupted playing time. It's a shiny silver color metal disc of 12 centimeter diameter, and it is made up of three layers, that is a polycarbonate base, through which light can pass, a layer of aluminium, and a protective layer of acrylic on the top of it. So it's usually zero point 0.5 microns wide, that is thickness of the CD, and 0.83 to 3 microns long, and 5 microns deep. A CD has one track that spirals from the center, as I shown you in the last slide. So it does not have these partitions as magnetic disc, but it's a single spiral from the edge to the center of the CD. And this single track is divided into several sectors of length and density depending on what has been stored in the CD. And some files are stored in these sectors. So different form of CDs are a CD-ROM, CD-R, that is recordable, CD-RW, that is rewritable. CD-ROM is like read-only memory, that is you can only read this CD. That some of the CDs that we get have songs that we get in this a shop, a music shop, we call that a CD-ROM. That is, you cannot write anything to the CD. Okay, the blank CD what you get, okay, that we call it as a CD-R, that is CD recordable, or that you can write something to this. Okay, so that is a CD-R. And CD-RW, that is a rewritable. Rewritable is little costlier compared to your just recordable. And in recordable, only once you can record, and once it is, and we call that process as burning. We call it's a burning the CD, burn something to the CD. Okay, and once it is recorded in this R, you cannot erase it, it's a permanent one. Okay, and once that process of burning is also done, you cannot add one after the other. That burning has to be done at once. Or there are software asks for a question whether you want to burn the CD after some time, any other any other information after some time. So if you give a yes, okay, in the multiple sessions you can actually burn the CD. Otherwise, only once you can burn the CD. And in rewritable, it's not like that. You can erase the information whatever is stored, and they can again write on the CD. So usually CD-ROM, as I told you, comes with the pre-recorded data, and R allows you to write the data which cannot be altered, and RW is rewritable. R means that is allows writing, erasing, and rewriting several times. That is RW. Okay, and data written in CD formats can be read only with the help of a CD drive. But as I told you, if you use a Blu-ray disc drive, CD also can be read, DVD also can be read, as well as a Blu-ray can be read. And they need special peripheral known as CD writer or CD burner that should be there in your system to read the CD. Write the CD or rewrite the CD. How the information is read? We have spoken about how it is actually inserted, that is, data is put into the CD. How it is read? CD drive reads the information through the CD spiral track pits and lands, starting from the center and moving to the outer edge. Light beamed from a semiconductor laser, it passes through a bottom of polycarbonate layer, and the aluminium coating monitors the light being reflected. So based on this, CD is read through the bottom of the disc, which pit appears as an elevated bump to the reading light beam, and the light striking the land areas are reflected normally and detected by the photodiode. So this is reading data from the CD. See, this is CD is entered. This is the drive. See, this is the drive. You enter it and it goes inside. This is the optical drive, disk drive. So this is the CD or any optical disk that you have entered. So see, this is how it looks like, that refracted, information on the CD. That is, see, from the behind, as I told you, we don't write up on the CD, that is above the CD. Everything is written like, at the lower end, that is the back side of the CD. So what happens? So the light is reflected, so laser bases are just pass through it. This is the reflecting surface, and when the information is just gathered, it is converted to electrical signals, and again it is being sent to the system, like what the information is actually stored. So it rotates around 200 to 500 rpm and bounces back if some information has to be given. And the reflected light passes through the prism and then to the photosensor. From pit, it is around 180-degree out of the phase, and land from the ends. Differences in the intensity is measured by the photoelectric cells, which converts into corresponding to electric pulse. That is, the mechanism used, as I told you, is a light, and when the light just passes it back, it is converted into electric signal and the information is read from the system. So writing a data, again it's the same thing. This surface is reflective, and laser can shine through the dye and reflect off the gold layer. That's something that shines, okay, for that it's called so. And for a CDR, that is recordable this to work, there must be a write drive. See, CD, just if it is a reader, you cannot write on it, so it needs a hardware support also, so that has to be an write drive. And CD, if it has an extra layer, that is, you can modify it as a greenish dye. The color will be a little greenish, and when the data is written, the dye layer changes its transparency. That is, I told you, only once it can be written, so it changes its transparency, and after that you cannot dye anything on this non-reflective bump. See, a small space how it looks. This is the laser head and it passes the laser light. So this is how it looks like, the wave pattern. So if you see it individually, it looks like this. The marks on the die, on the spiral, whatever the pits or the land that is present. Decomposition of the dye in the pit area through the heat of the laser is irreversible. As I told you, it's permanent. You cannot redo that. Once again written on the writable CD, you cannot again erase that. And CD and write drive should be there to modify, otherwise you cannot modify there. And rewritable, it's use a changing material, it's recording layer, usually alloy of silver, tellurium, tellurium, indium and antimony metals are used. And these are, because these are phase changing metals, that is, when heated they lose their you know um, the basic property, you can say, or they just lose their original state. And when that again the right amount of heat is given, again they come back to normal, or at the room temperature they come back to normal. So it's a polycrystalline structure. The CD or the rewritable has a polycrystalline structure, and while writing to this, it the laser heats up the selected areas to very high temperature and melts the crystals to non-crystalline amorphous phase. And these areas have lower reflectance than the remaining crystalline areas, and this is why zeros and ones are formed on this disk. This difference actually helps in reading. So once you write into the CD, you can read, you have to read it, right? So this difference helps the system to read the information on the CD or the optical disc. And the erasing of this is called as annealing. One layer that has been changed to amorphous phase is converted back to original crystalline again by heating. Okay, the same procedure is followed again. Next is the DVD. It's also called as a digital video disc. has a sevenfold increase in data capacity compared to CD. So DVD has almost 7 times more than the data capacity of the CD. Again, the whatever the information or the read or write thing happen, that's same thing for the DVD also. But the it's just difference that single layer of DVD is zero point 0.4 microns compared to 0.834 microns. That is the minimum bit length of a single DVD. And laser used to create bit was a range from a 635 to 650 nano meter. So this is the in CD and this is in the DVD. So the length is zero point 0.8 micrometer and zero point 0.4 micrometer here for the DVD. Okay, the thickness, there is a increase in thickness here, so there is a decrease in thickness. So this is how a DVD looks like, usually a little darker, and you cannot see that reflection that is seen in the CD. Okay, and it's simply working is similar to your CD. So the second layer can be read from the inside disk out as well as from the outside in. The second layer of the each disk is recorded backwards or then reverse spiral track. That is why you can have this large number of space. See, otherwise the space or the the you know the surface area whatever is present in CD and DVD is almost the same. It's not much difference. Then why the space of storage in DVD it's more? Because it is stored in layers in DVD, and whereas in CD it's only made up of one layer. Okay, and small pits manufacturer use a thin plastic substrate, thereby reducing the depth of the plastic layer, and that has a much just coats or the layers of coating is higher. See, there are two types of DVDs again, that is one-sided and double-sided. So that is this here. See, only in the below it is present the and single-sided double layer that is also present. This is single-sided, double-sided single layer. There is up also there is a layer and down also there is a layer, and this is double-sided double. The 17 GB of data can be stored in a DVD. One more is the Blu-ray disc. So again, it is similar to this DVD itself, but it can have a high definition video and audio storage, and it can be used to record. So it is developed by BDA, that is Blu-ray Disc Association, and it has a blue violet laser having shorter wavelength compared to your red laser. Okay, and due to this shorter wavelength, laser can be more focused compared to the red laser. Okay, and the storage capacity around 10 times that of a DVD. So this is how a Blu-ray looks like. So in different forms they are available, like again BD-ROM, that is only read only, then is recordable, then re-recordable or rewritable, and rewritable for high definition. Okay, so these are the formats available. So it comes in two different sizes, the 12 centimeter and 8 centimeter, and again they have single or double layers depending on what the data capacity is needed. So a single layer is of 25 GB, a dual layer is about 50 GB, almost the double, and a mini disk with a single layer is 7.8 GB, dual layer is about 15.6 GB. So one can edit the programs recorded on the disk or change their order as one requires. And you can use have a playlist program stored on disk, so that can be randomly accessed, allows to write one program while simultaneously watching another program on the same disk. So totally, what are the advantages? Mainly compared to your magnetic disk, it's a large capacity ones, large amount of data can be stored compared to your floppy or zip disks. Lifespan is more, but the thing is you need to store in a very clean environment, and more recording density, that is the physical space available and the amount of data you can store, and they are not affected by magnetic field. So if you have the magnetic disk, if some of any magnetic devices come near it, there is a chance of getting the data getting erased. But optical disk, since it is read by the optical, all the lights so it is not affected. And it's hard to break or melt, which physically strong usually, like by itself it does not get spoiled or get corrupted. But if you put much force on it, it obviously it will be going to break. And again, easily portable, it's very lightweight. I have seen the CDs and it's very lightweight. Then what are the disadvantages? It's compared to floppy and zip disk, it's costlier. But when compared to the amount of information it can store or the storage space available, it's a very cheap. And it's not as easy to copy. That is, I told you, you need to have the drive, a separate drive for the if you want to write it. And also you need to have that process, we call it as burn. That is, once it is done, then it is over. You cannot rewrite unless it's a rewritable one. And they possess low data access speed compared to the magnetic disk. It's not that slow, but compared to magnetic disk, it is slow. And drive mechanism is more complicated. It's not as easy as the magnetic disks. So to overcome the disadvantages of both magnetic and optical disk, there is one more thing that was invented. We call it as a magneto-optical storage devices, which we'll be seeing in the next video. Thank you.